You guys should be seeing the Couch Wars local multiplayer splash screen. That is a picture of the project we're going to be working from, the 2D platformer. So grab that and get it going. If you haven't already, I've got a new empty project with the 2D platformer project imported. That's a free project on the asset store. Just search 2D platformer from the publisher Unity Technologies. No split screen in this, as Invincible Cat asks. We are going to be doing single screen, 2-controller local multiplayer. We'll start by modifying the project to get it working with 2 people with hands on a keyboard, and then we will hook up the controllers in the second half. So you should be seeing the Unity editor now. We've got our project loaded with the 2D platformer package imported. And so the first thing that I'm going to do is open up in our scenes folder. I'm going to open up the scene called level. This is the main scene in our game. We don't need to save this. And I'll just give this a quick test for those of you guys who haven't seen it. Let's play the scene. Going to repack our sprites. That's fine. Only happens the first time we play. All right, so we've got this little potato man here. He can shoot rockets. Move to the left and the right. In this case, I'm using A and D keys. You can also use the arrow keys. Shoot rockets, and if you push the mouse 2 or Alt key,
bombs away.
There it goes.
Keep it classy.
We can drop these bombs, and if we run out of health, we will fall off the screen and restart the level. So what we're going to do is we're going to adapt this so that we can have 2 of these guys running and jumping around and controlling them simultaneously, at first via keyboard, and then second using 2 Xbox 360 controllers. Now, the first thing that we're going to do is let's just get our camera adjusted. Right now, the camera is following the player, and so I'm just going to grab my main camera, deactivate the camera follow script that's on here just by unchecking it. And I'm going to zero out the X and the Y axes to center it, and then I'm going to set the size here. The camera is in orthographic mode, which will be the case if you've loaded with the 2D defaults. And then I'm going to set my size to 18, just so we can see the whole, probably even go 17, let's see. Yeah, just so we can see the whole playing field here, the whole level, without having to move the camera around. Because, you know, we're not doing split screen. We don't want one of the players going out of the view of the camera and not being able to be seen. Okay, so what we've got here is we've got our hero. There's a player control script, which controls moving left and right and jumping. There's a lay bomb script, which allows us to lay the bombs. And then on the gun object, there is a gun script. And so what we're going to do is we're going to start by setting up some new axes in the input manager to manage our new 2-player input configuration. So we're going to go up here to Edit, Project Settings, Input. This will appear over here on the right side of the screen, and then we're going to click this fold out to expand the axes, and let's take a look first at our horizontal axis. Now, I'll just take you quickly through what each of these fields are, and then we'll get into setting things up. So the first thing that we have is the name, which is a string, and this is the way this is going to be addressed via script. So we will be using commands like input.getAxis, in this case horizontal, and so we're going to use the string here to define what axis we want to be getting input from, and so this is fairly important, and we're actually going to be modifying this in a moment. The descriptive name for the positive and negative buttons is what's going to appear in the loader, which if you build a standalone version of your app, it's the little window that pops up before you launch your game and allows you to do things like choose the resolution and to remap the controls. And this will be the string that will describe what each of the buttons do in that screen. Here we have negative and positive buttons. The main ones are set to the left and right arrows on the keyboard. And then we also have alternative buttons, which in this case are set to A and D. familiar from your kind of traditional PC WASD style controls. So A to move left, D to move right. And then we have the gravity. The gravity is what's happening when we give a piece of input is that it's setting a floating point value between -1 and 1. And if there's no input, it will be 0. The gravity controls, when we go to 1 and we let go of a button, how quickly is this going to return to 0? Is it going to kind of jump back to 0 quickly, or is it kind of drift back down? The dead zone, or dead here, is for a joystick control. Because analog joysticks constantly give out values and may be giving out very tiny bits of data, even in their idle position, because it's a piece of analog physical equipment, you want to ignore that tiny bit of data. And so you'll see in some of these predefined axes, like for example, the joystick axis down here, the dead zone is set to 0.19. So that's 0.19 out of floating point value of 1. And so kind of the lowest 20% of values are going to be ignored. And then we would need to get to 0.2 or above to start actually reading input and moving the character. In the case of this keyboard axis, this is irrelevant. And we could just leave it at the default. The sensitivity is how fast this responds to input. And so generally you want higher values for a faster response. So you'll see for things like the fire button, it's set to 1,000. But in this case, because it's a movement, we've got it set to the default of 3. Snap is on. This is when we are changing directions. So going from the left, let's say we're moving left, and then we want to change to right. The snap is going to decide, are we going to kind of interpolate back across, or are we going to just jump our value, make an abrupt transition, let's say from a positive to a negative value. Invert just allows us to reverse it. So in this case, this would swap the left and right directions. The type here, we're using a key or a mouse button because this is for the keyboard controls. We could also use mouse movement or a joystick axis. And we're going to do some stuff with joystick axes in this session. The axis in this case, which would be reading from the mouse or the joystick, is going to be the x-axis, the horizontal axis. For a button, it doesn't matter. And then the joystick number, what joystick we're listening to or what joystick we're taking input from, is also irrelevant for this because this particular axis is not taking joystick input. But we can use this to choose which of our connected joysticks we want this to be listening to. Okay, so what we're going to do is we're going to start remapping this to take advantage of two-player input. So the first thing that we're going to do is we're going to start by changing the names. So we're going to add an underscore P1 to our horizontal axis. And so this is going to be the player 1 horizontal axis. Now we're using 4 axes in this project. We've got horizontal movement, fire 1 to shoot the rockets. And so we're just going to append our same underscore P1 to fire 1. Fire 2 is to lay the bombs. So we're going to add, again, I'm just pasting in the underscore P1 at the end of that. And then jump, we're going to do the same thing, right? So what we've done is we've now made each of these default axes specified that these are going to be the axes for player 1. Now, what we're going to do is we're going to add some axes. Oh, and of course, we're going to do this as well for our horizontal joystick input, which is predefined. And we're actually going to make one more tweak to that, which is that for player 1, we're going to get motion only from joystick 1. Okay, now we're going to add to our list some axes for player 2. So let's just collapse these. And we're going to set this to 23, which is going to be the final number of axes that we're going to have. It's added a bunch of additional axes down here, and we're just going to start. I'll just copy this string. And so this is going to be horizontal player 1. I will use the negative button J and the positive button L. So we're going to do an IJKL movement scheme here for the keyboard controls. And of course, we're going to set this to horizontal player 2. And let's just duplicate the settings that we have for the first axis. So 3, 0, 1, 3. We can leave the joystick. Actually, let's delete the joystick stuff just so it doesn't get confused. We will actually add joystick buttons here, but just for now, we're going to take that out. And that should be good for our horizontal. Let's also add We will copy. This is going to be fire 1, player 2. And the positive button, let's use the right control. So we're using left control for fire 1, player 1. We'll use the right control for that. We'll get rid of the joystick. And just, this is actually, this will be fine, these settings. And we'll do the same for jump. This is going to be jump P2. I'm going to use the W key, the I key, which would be like up in our IJKL pattern. Delete this. And let's add, I should have put fire 2 there. Let's actually put fire 2 there just to keep things organized. This will be fire 2, P2, and we'll use our right Alt button. Jump down here just so we can kind of keep track of where everything is. This is going to be jump P2. Use that I key. That's fine. And what am I missing here? That's, oh, and then this is going to be our second. Let's just we'll set it up now. This will be our second horizontal player 2. This will be for the joystick. And I'll configure this in a moment when we set up the controller controls. Michael Miko is asking how I made new axes. I did this just by changing the size. It was originally 18, and I just highlighted that and changed it to 23, which will add, in that case, 5 new axes. Question is, wouldn't it be faster if I right-click on the input? Yeah, that would be fine, for sure. We could right-click and duplicate array element to do that. That's a good point. Now, doop. Yes. Okay, we can close all this up for now. Alrighty, so what we're going to do next is we're going to modify the existing scripts so that they can take advantage of those axes. So let's see here. Okay, so let's start with the player control script. So I'm just going to double click this and let me zoom it in. Okay, hopefully that's big enough for everybody. And so I'll give you a quick kind of superficial run through what's going on in the script. Please note there is a full series of tutorials about creating this project. So if you want more details about how this project itself works, go check those out. I'm just going to run through very, very quickly just so we can kind of know a little bit about what we're doing. So basically what's going on here is in our update function, we're doing a line cast down to check if the player is on the ground, right? Is not in the air. Then, if input get button down jump is true and grounded is true, meaning we're sitting on the ground, we're going to set our Boolean, our public Boolean jump, which defaults to false, to true, right? Meaning it's okay to jump. In fixed update, which we're using for all our physics code, if jump is true, we're going to set the trigger of the animator controller. We're going to choose a random jump sound to play and then add force to our rigid body 2D to make the rigid body 2D attached to the player move and jump, right? And then we're going to set jump to false so that the player can't jump again while they're in the air, right? So we can't double jump. Also in fixed update, we've declared a float called h, and we're setting that to equal the value currently coming in from the horizontal axis, right? So we're using input.getAxis horizontal to set h to equal the input from our horizontal axis. Then here we are making sure that we're not reaching the max speed, right? We're not going to exceed the max speed and add force to the player. And you can see all this stuff is commented pretty nicely in these scripts. So you should be able to kind of go through and puzzle it out if you're curious. We don't actually need to work with any of this. What we're just going to do is change the strings here that we're using. So if we look at this, right, we can see these are the two lines that are relevant to us, right? Where we're doing input.get button down for jump and input.getAxis horizontal. And so you'll notice that these are both strings which we're using to address the axis of that name in the input manager, right, by the name. So what we're going to do is we're going to turn these from hard-coded strings into variables so that we can adjust them in the inspector. So we're going to add two public variables of the type string. So we're going to say public string jump button. And we're going to set that to equal. We'll set a default value to jump underscore player 1. And then we're going to do the same thing for public string. We'll call this horizontal control. And that's going to also default to horizontal underscore player 1. And now we're just going to replace the hard-coded strings with our string variables. So here, jump. Make sure you get rid of the quotation marks. And horizontal control. Boom. And that's actually all we need to do for the player control script. Let's save. Jump over to the editor. And then we will see, when this updates, that the player control script now has these additional fields with correct default values for player 1. So our jump button is going to be jump player 1, right, which is the jump axis, the original jump axis, and then we have our horizontal P1 movement axis. Well, let's now do the same thing for the lay bombs script. So we're just going to double click that to open it up. And just really, really similar what we're going to do here. Here, we're checking if input.getButtonDown fire2 is giving us a positive value. And then we're going to check also if bomb laid, this Boolean, public Boolean bomb laid is false, right? So a bomb hasn't been laid and our bomb count is greater than 0, then we're going to instantiate a bomb. Now, let's just take a quick look at the bomb script, and what we'll see, this is kind of one of the first potential issues here. The way that the bomb script is telling the player that the bomb has exploded is by finding the player object with tag here in awake and getting a component reference to lay bombs, which it's storing in this lay bombs variable. So we have a private variable of the type lay bombs, right? The class lay bombs called lay bombs. So we're getting a component reference there so that we can set the values. But the problem with that is if we have two players and we're finding game object with tag, it's just going to find the first one and ignore the other one. So what I'm going to do here is I'm actually just going to deactivate that. I'm going to take out the check for if a bomb has been laid, and I'm going to take out setting bomb laid to true. And so now the player will be able to lay multiple bombs up to the number of bombs that they have. So, you know, certainly there might be a more elegant solution there, but for this, I think this will be totally fine and is totally fine gameplay-wise. So let's save that. Oh, sorry, let's add our string, right? So we're going to add a public string called bomb button and set it to equal fire2 underscore player 1. And then we're just going to add that in where we're checking for our fire2 input. Save. And then in the editor, we're just going to edit our gun as well, our gun script. Okay, Bob Swinkle's asking, can we just replace jump with jump player 1? No, because what we're going to do is we're going to duplicate this player to make our second player, and we want to be able to define where he's getting input from in the editor, not hard coding it in the script. I mean, you could say if it's equal to, you could do some other more spaghetti-like code, but I think this was the cleanest way I thought of to do it. So let's do the gun script real quick. Exact same workflow here. Just going to open it up. I'm just going to go straight in. We'll just add our public string gun button. Set this to equal fire1 underscore player 1. And yeah, here again, we're just checking if get button down fire1 is positive. We're going to set the animation trigger to play the animation, play our audio clip, check if the player is facing right, and then instantiate the rocket facing right, and otherwise fire a rocket to the left, right? So the direction the rocket goes in is based on the direction the player is facing. Okay, let's save that. Jump over to the editor, and then we should see that appear here. There we go. Okay, good. Now, that is all we need to do for the control scripts. There's one other thing in here that's set up in a way that we're going to want to change, which is the health bar. If you take a look, we've got this nice green health bar that scales and gets shorter as the player gets hit and also changes color. And so, but the issue with this is that it is an independent object that's just following the player. And what we're doing is in the player health script, we're getting a component reference to the sprite renderer and scaling it and changing the color. What I'm going to do is I'm going to do, and so if we take a look, let's go down to our player, open our player health script here. We can see how that's happening. So here we have a private variable of the type sprite renderer called health bar. And again, in awake, we're doing GameObject.find by name health bar, and then doing a get component to get a component reference to the sprite renderer, storing that in health bar, and so that then we can do things like, where is it? Somewhere, take damage, here we go. Health, no, somewhere it's the health bar is in here. Update health bar, here we go. Health bar.material.color, and then we're lerping between the two colors, and the local scale, we're scaling the size, right? So what we need to do is just have a public reference to this sprite renderer, and we're going to leave out this find because, again, it's going to find it, but if there are more than one, it's just going to find the first one, and then we're only going to have one of our players with a health bar. So I'm going to comment that out, and then we're just going to make this a public variable sprite renderer health bar and save that. And then in the editor, we are going to child the whole health bar object here to the hero, so that now we can drag in to our health script here. Now you see we have a public slot for our health bar. We'll just drag the health bar object into that slot. It'll get a reference to the sprite renderer, and it'll be able to update it and to change it. The other thing that we need to do is to be able to make it follow it. It's doing the same thing with follow player. If we open up follow player, super simple script here, but again, GameObject.find with tag, it's using that to find the player, so we don't want to do that because, again, we have two players with the same tag. It's going to just get one of them. So, again, we're just going to make, so we're just getting the transform, right, and storing it in player. So what we're going to do is just do that by dragging. We're going to take this transform, make it public, save it, and then over here, we are going to, this should appear, there we go, there's our reference to our player, right, and we'll just drag in the transform, the game object for the hero, which will get a reference to the transform. And now, let's just confirm that that works. So there we go, it's following our player still, and the, and updating the values. Now my, yeah, so that's good. Okay, so now we can actually duplicate. We've done the work that we need to do. Now we can just duplicate this player. So let's call this hero P1, and then we're just going to hit Command D or Control D in the editor to duplicate him in the hierarchy. And name this one hero player 2, and let's move him to the other platform here. And now all we need to do is to change these strings, right? So now this is going to be player 2. Player 2. In the lay bomb script, we're going to set this to player 2, and then the gun is going to be the same. Also player 2. And so the health, because we dragged in references that are all attached to the same object, you'll see this will just maintain that, right? So here, the reference is now to hero player 2. The health bar is there. Now, let's just give this a quick test. We've redefined our axes for player 2. And let's just make sure they're working. So yeah, so I'm pressing J and L. Ow. We can move. Get stuck here. Good. So that's all fine. Let me just oh, they're both firing at the same time. Hold on. Something's wrong here. The gun. Fire 1, player 2. Let me just make sure. Oh, I must have. Hold on. Let's see if I messed it up in the input manager. Derp. Let's take a look. What did we do here? Gun. Oh, der. I didn't. There we go. Okay, that needs to be gun button. Thank you. There we go. Okay, all is well. So, for those of you guys who may have followed me making that mistake, I forgot to paste the gun button string into the check for input here in the gun script. I was just zipping along a little too fast for my own good. This is why this is fun doing this live, right? You guys get to see me make mistakes. All right. So now we've got a little local multiplayer game, right? Simple local multiplayer game. Let's just change the color on the body. Make it a little more. We'll make this guy red. How about that? He could be like evil Potato Man. Just so we can keep track of who's who, right? Evil Potato Man versus good Potato Man. And then there was a question as well in the chat about, are you going to add a co-op versus so the score is either the same or different? We definitely, let's see how we do time-wise. We can adjust the score. I wasn't actually going to do that, but if we get done early-ish, which I think we could take a look at that. Now, this is a point where, for those following along on Mac and PC, it's going to be a little bit different because the button numbers of the Xbox controller, or really whatever controller you're using, are going to be a little bit different. Now, I will just show you quickly a picture. This is the layout for Mac. So this is the layout for Mac. This is using the Taddy Bogle OS X 360 controller driver. Now, worth noting about this, I suggest if you're on Yosemite that you grab it from this link, because this was the only one that I found worked. Yeah, there you go. This is the only one that I found worked in OS X Yosemite. You should be able to use the one from the Taddy Bogle website that's up to version 12. That'll work fine for other operating systems, but if you've upgraded to Yosemite like me, you're going to need to grab this unofficial one to get two controllers to work. One was working fine with the old driver, but anyway, I'm sure that'll change over time. So for those of you watching on YouTube, you can probably safely ignore that. Okay, and then we also have controller numbers for the PC, for Windows, where you will not need a driver. You can just hook up your, because it's both Microsoft products, you can just hook up your Xbox 360 controller, and these are going to be the button numbers. So instead of 16, 17, 18, 19, we have 0, 1, 2, 3. And actually, I'm pretty sure these will just work by default in Unity because it's mapped out that way. You'll still need to do some tweaking for the two controller support, and that's what we're going to do now. So, you know, when hardware is involved, your mileage may vary, but hopefully that gets you guys started off on the right track. Let's open back up the input manager. And so what we're going to do is we have already predefined our horizontal axis, which we renamed horizontal player 1. And this has set up a joystick axis, right? So this is set to joystick axis. The axis that we're reading is the x-axis. And I set this to joystick 1 earlier, right? If it's not, you're going to want to set this to joystick 1 so that player 1 will only receive movement input from joystick 1. Now, what we can do is we can duplicate this, as suggested by some of our friends in the chat, which is a good suggestion, and change this to player 2. And then we're going to change joystick 1 to joystick 2, right? So now we have two joystick axes with the same names as our other axes set to joystick 1 and joystick 2. And that's really all we need to do to get the analog sticks working. And now what I'm going to do is I'm going to set my fire and jump buttons to buttons on the controller. I'm going to use the Alt positive button fields because I don't think we really need two. We need alternate keyboard buttons for this game. We could just have one set of keyboard controls and one set of controller controls. But what you'll see in the default mapping is they have set up a whole alternate mapping for joystick. So you could have two keyboard controls and then another axis For the joystick, I'm just going to do it all in one axis because I think that'll be fine. So here, what we're going to do is instead of mouse 0, which is the mouse left click, we're going to change this to be joystick 1 button. I'm going to use button 17, the B button on the 360 controller for fire. So this is important, right? You could, if this was only one controller, you could just type joystick button 17, right? But we're going to do joystick 1 to specify what joystick number we're getting our button press from. And we don't need to set it down here in joy number. So I'll just copy that. Let's go to fire 2. And again, our alt positive button field, we're just going to put in joystick 1, and this will be button, let's use button 19, which will be the Y button, the yellow button. And then for jump, player 1, same thing. That's not the negative button, right? Joystick 1 button 16, which will be the green button, the A button. And now we're just going to do the same thing for fire 1, player 2. Alt positive button is going to be joystick 2, button 17. Fire 2. Alt positive is going to be joystick 2, button 19. And jump is going to be, alt positive is going to be joystick 2, button 16. And now that should be good. So we've redefined our horizontal joystick axis, right? Which is going to be, whoops, no we didn't. Wait, why is this? Oh, sorry, that's the keyboard. Let's just double check this. Here's horizontal player 2. Yeah, joystick. It's a joystick axis. And on the x-axis, enjoy number 2, and that should work. And now let's give it a quick test. Grab my controller here, and yes, player 1 is working. Ow. Shoot. Ow. Player 2 is getting robbed. Ow. You can grab the bombs.
I defy you.
I defy you.
Bombs away.
All right, cool. So he's working. Barely alive. He's dead. He died. All right, let's try it again. Not very good at this game. Okay, jump is working.
Let's have you. Bring it on. I defy you. Bombs away.
We got it. All right, cool. So that is all working nicely. So, you know, fairly straightforward process there. But hopefully fun and gives you some ideas for your own games and kind of for setting things up in your own games in advance, right? So that you don't write a lot of stuff doing, you know, find object with tag or you know, checking tags or checking the name or anything like that, so that we can try to make stuff that if we wanted to add co-op play, for example, later in development, we could. All right, so how are we doing on time? Okay, 3:45, not bad. So let me just answer some questions for the chat, and then if we have requests for other features to add, we can look and see if we can do them a little bit quickly. How would you handle split screen multiplayer's audio? Yes. You know, so here's the question. How would you handle split screen multiplayer's audio as Unity allows just one listener? How would you handle this? Invincible Cat, this is a very good question. What I would tell you is, if you think about it, if you're in a split screen multiplayer situation and usually, right, we have two players playing on the same TV or the same PC, they're going to be listening to one set of speakers, right? So you really could just blend the audio. What I would do is I would basically do flat 2D audio, right? I would avoid providing spatial cues through the audio because it's all going to get mixed out of the speakers anyway. And like, how is player 1 going to know that this audio is intended for him if it's coming out of the speakers, right? And most TVs don't have like 2 headphone jacks or anything like that, right? I would just say flatten out your audio, do it basically in 2D and, you know, mix it all out to the speakers that they're both listening to. How do you set audio to be listened just when the player is in a certain section of the 2D screen? I would just, let's say, maybe put a trigger on that section of the screen and activate or deactivate the audio sources based on that. That might be one way to do that. Cool. All right, great. So let's see. So what were our requests here? So let's take a look at the score thing first. Let me just see. Oh, see, this is still a GUI text, the score. This is pre 4.6 UI, but this is actually, let's take a look at where the scores get. Okay, this is something I didn't prepare, so I'm just going to have a pick around here. Where's the score getting updated? I wonder if the enemies are updating the score, actually, probably. Let's take a look. Let's look at our enemy prefabs. Enemy 1, I assume when the enemy dies, he's updating the score. Let's see. Is there a reference to the score? Points UI. Let's just see. No. Let's just see what happens when he dies. Death. Score. Okay, there's score. Score.score. Score. Okay, there's a script called score. That's what I need. Shooby-doo-wop. All right. Score. Okay. Oh, okay. Player control. Previous score. Getting a reference to the score has changed. Play a taunt. Okay, cool. GUI text.text equals score. Don't know. Here's the score script. Oh, I see. It's just adjusting. Okay. Enemy. So actually, this is not as easy to change, right? Because the enemy is just the enemy doesn't know who killed him, right? So what we might have to do is add some kind of variable to the rockets to tell the enemy when I'm pretty sure the rocket, let's look at the rocket script. Okay, so yeah, when the rocket hits an enemy, it's calling the hurt function, right? And what we could do here is we could pass in some info, you know, maybe a player number variable, or maybe we give it probably a player number variable, right? To say which player killed it. Let's see if we can do it quickly. How are we doing on time? Let's give it a try. So let's just say public int player num, set that to equal 1. And okay, what we could do is we could say hurt. Okay, so hurt doesn't take a parameter, right? So let's give it a parameter int player shot me, player who shot me. And when we call this, we'll pass in the player number. So rocket. Yes. Okay. Hurt here we'll we will pass in player number, right? So now the player knows who shot them, the enemy knows who shot them, right? Okay, let's follow through. So what we're gonna do is we're gonna have to make a second rocket prefab, right? So props. This is under props. Rocket. So this will be rocket player 1. And this will be rocket player 2. So that now we can specify separate values. And why is this? This is throwing an error because I didn't save the enemy script. Hurt does take one argument. I just gave it an argument. There we go. Okay. So this will be player 2. All right. So now it should be able to know. So now player who shot me. And we will say, this is super ugly. Okay, but I'm just going to, since I started, I'm going to follow through. Okay, so let's add, we can add a private int called player num. And in hurt, there's certainly a better way to do this, but we'll just say player num equals player who shot me. And then here, I'm just going to do this kind of a little bit hackishly. What is score? Score script. Getting the reference to that. Game object find. Basically, we're going to need to pass info. So we've got the player number who shot me, but now, again, it's doing this type of thing where you're doing game object find by name ends up being can be a little rough, right? When you want to start extending things, like the situation. There may have been a much better, cleaner way to do this, but I can't think of it right now. I mean, we could say, right? We could do this, right? This would be score 1. We'd have score 1 and score 2. Oops. This will be we'll find score 1, right? Where's it? Score. This is going to be score 1. And let's just move it over some. This would all be different using Unity Engine UI, by the way. So drop shadow as well. And then we're going to make, this will be score 1 shadow. Score 2. I'm just going to leave off the drop shadow for now. And now, right, we could say find score 1. Find score 2. So score 1 is this, score 2 is this. And then I feel like this is ugly, but we'll just do if player num equals 1. We'll update score 1, right? Else score 2 dot score plus equals 100. Let's see if that works. I feel like this is not elegant, but let's just see. I think it'll work. Oh, and then we need to make sure that they're both shooting the right types of rockets. So gun is shooting rocket player 1, and you are shooting rocket player 2. Dupe. Okay, now let's try and see if it works. Ow! Ow!
Tally-ho!
Yeah.
Ow! Oh, high five!
Okay, it works.
Ow! Ow!
Not gorgeous and elegant, but it works. So, yes, there you go. All right, let's see what else people are asking about. Hybrid Spider, something like GameObject.find score plus player number. Yeah, that's actually probably a cleaner idea. That's not a bad idea. Just append the player number to score. Good enough for a game jam? Exactly, Benjo72. Good enough. Thanks, Oboe Shape. Just hacking our way through here. Minecraft and Unity. FireDan, there's a lot of people who have talked quite a lot about voxel-based worlds, which is what Minecraft is based on, and block worlds and stuff. In Unity, I would just have a look, or do a little quick Google around. Again, I think it's probably more than I could do in an hour, but plenty of people have thought about that question and come up with some solutions. What I am trying for my current project is Perlin Noise procedural terrain. Cool. I think that is cool. You know what you should check out, GM Liquid Media? There's a cool talk by the guys who did Sir, You're Being Hunted about procedural generation. They did that game in Unity, and they show some of their procedural generation approaches, which are cool. How would you do crouching with the standard FPS controller? I would just change the height of the camera and maybe change the size of the capsule collider, whatever you're using for the collider, when you press the crouch button. Later, Invincible Cat, thanks. Yeah, guys, I think I'm going to, because we're coming up on 4:30 here, I'm going to start to wind down as well. I'm going to go off mic and give my voice a rest, but I will keep the chat going. And thanks, everybody, for stopping in. It was fun, as always, and thanks to those of you helping out in the chat and answering questions as I'm talking away. And I look forward to seeing you next time.